Improved customer engagement. IoT allow you to improve customer experience by detecting problems and improving the process. Disadvantages IoT. Now, let's see some of the disadvantages of IoT in this Internet of Things tutorial. Security. IoT technology creates an ecosystem of connected devices. However, during this process, the system may offer little authentication control despite sufficient security measures. Privacy. The use of IoT exposes a substantial amount of personal data in extreme detail without the user's active participation. This creates lots of privacy issues. Flexibility. There is a huge concern regarding the flexibility of an IoT system. It is mainly regarding integrating with another system as there are many diverse systems involved in the process. Complexity. Complexity. The design of the IoT system is also quite complicated. Moreover, its deployment and maintenance also is not very easy. Compliance. IoT has its own set of rules and regulations. However, because of its complexity, the task compliance is quite challenging. Summary. Introduction of Internet of Things IoT. The Internet of Things is a network of physical objects or people called things that are embedded with software, electronics, network and sensors, which allows these objects to collect and exchange data. The actual idea of connected devices was proposed in 1970. Four key components of IoT framework are sensors or devices, connectivity, data processing, user interface. Various applications of IoT are smart thermostats, connected cars, activity trackers, smart outlets, connect health, etc. Technical optimization, improved data collection, reduced waste, improved customer engagement are key benefits of IoT. Security, privacy, complexity, compliance are key challenges of IoT. We are going to discuss the project requirement. So the topic of this project is an IoT based home automation solution. The project consists of three main parts: garden lights control, temperature control system, and water tank inlet and outlet valve control. Also, we are going to control these various parts with our mobile devices with the help of an application called Blink IoT app. So, firstly, we are going to divide these three things into three small mini projects covering the various aspects of each individual devices or sensors that we are going to use. In first mini project, we will measure the temperature and view it on the dashboard. Second mini project is going to cover CLCD or commonly referred to as dashboard. Third mini project is going to be covered on LED and LDR sensor. Fourth is going to be the cereal tank. Then we will complete the mega project. Before dividing into the projects, let's cover the softwares we are going to use here. Arduino IDE. Since we are going to use the Arduino Uno board, we are going to use the Arduino IDE to code the program. SimLabs simulator. This simulator simulates motherboards. We are going to use the Arduino Uno and the serial tank simulator. Null emulator. It is an emulator which connects the Arduino IDE with the PixSimLab simulator. There are two ports which connect these both devices. We are going to use two ports, COM1 and COM2. Blink Cloud and Blink IoT app. This cloud service connects our Arduino board to the cloud with the help of internet to create a remote connection for our automation and ease. So, let's discuss the first project in detail. Let's talk about our first mini project. Our first mini project has more than one spare parts and they are mainly CLCD or the dashboard, heater or cooler. So how do we make it? First, we will create three files for our library in our main project. Those are main.h, temperature system.h and system temperature system.cpp. In main.h, we have defined V1 for temperature gauge, V0 for cooler, V2 for heater, V6 for a terminal in Blink. We are going to further use with pins that will help us connect with our Blink IoT app. In temperature.h, we have defined 5 for heater and 4 for cooler. We have also initialized A0 pin for temperature sensor. We have also initialized functions such as read temperature, which returns a value in float. Init temperature system, cooler control and heater control, which will return values in 0 or 1. In temperature.cpp, we have included main function, Arduino library and temperature system.h to create those functions earlier initialized. So, in first function, we take pin mode cooler as output since cooler is an output device and we use digital write to tell when it will stop. We use the similar logic in case of heater. Now, in read temperature, we first measure the temperature using the heater sensor, reading it on the ADC and then displaying it on the dashboard, and we return the temperature as floating numbers to get the actual and precise reading of the temperature. We use cooler control and heater control function to control them using our Blink app, which we will be covering later. Now, we will call that library temperature system.h in our mega project, and we will also initialize our CLCD or the dashboard function to display it on the screen. We use blink write function to create a logic as to when the value is true. It turns the cooler on, and if the value returns false, it turns the cooler off. Similar logic has been pasted in heater V pin. Next, we create a function which updates the temperature reading to the temperature gauge we will create later in our Blink app. Next, we create a function called handle temperature where we give an instruction to the heater saying it to turn off if the temperature exceeds 35 degrees Celsius and also if the heater is turned on during that time. Next, we initialize the heater and the cooler control system in our setup function using init temperature system that we earlier created and we update the temperature reading to our temperature gauge every 1000 millisecond or 1 second. We repeat the process using the loop function where we call handle temperature function. Now we are going to discuss our second project, that is the initialization of our CLCD device and how to use the dashboard and print values in it. As we already know that dashboard can only print stuff in characters and string. Every value that we return has to typecasted into a string to display it onto the CLCD. So here are few concepts we will be clearing out. First, we have to initialize the LCD using the library called liquidcrystal.i2c.h, which is a predefined functions come ready made with the Arduino IDE. We will use two lines in this dashboard, hence we will two lines for display which can only display 16 characters at a time. SetCursor function is used to write a value in that defined cursor. Let's say 00. This means we want to print a character in the first line and first character space 0 that CLCD. As you have seen earlier, in case of cooler, we have taken that values as 7, 0. That means we want to print the exact words starting from the 7th place to the first line. We initialize it in the setup using LCD Unity. We turn on the backlight of the dashboard using LCD dot backlight. We will clear the screen every time a character is printed to avoid overwriting. And every time a printing is complete, we will put the cursor in home